So we're going to talk about what we are doing with Presto at Facebook. And I know this is the last session that people probably want to be done, so I'll try to be brief. So here's our mission statement, which essentially includes everything except solving world hunger. But more realistically, it's around how do we create things that are fast, that are reliable, and it's the best of breed in the industry, while keeping the openness and the community. Right? That's what we're talking about. So I'll just go through a few themes really quickly. I think there are about 10 of them. And we'll talk briefly about what Facebook is doing for each of these, and how we are hoping that we take Presto forward. And by the way, I should put a disclaimer that I'm not responsible for any of this stuff. I'm merely representing the work of a lot of Presto engineers, many of whom are in this call, hopefully. So let's start with latency. I don't know why my font is so bad. Maybe I can. So I think latency is pretty important. A lot of us have been talking about latency. At Facebook, we want to take it to the next level, where I think Girish talked about kind of how we can do external serving using Presto. So we're talking about that kind of latency. We're talking about like tens of milliseconds at thousands or maybe tens of thousands of QPS. One thing that makes it interesting here is also that we want to do it with fresh data, not just kind of stale data, right? Which is an interesting challenge, like real-time data with really fast queries. So what are we doing there? There's a bunch of things. We are investing in smarter partitioning and pruning. I think this is super important because a good partitioning can reduce the fan out considerably, and you can get like many orders of magnitude speed up if you get the partitioning right. I think we know this. What is smart is essentially we don't have to kind of do it in a fixed way, right? We can do it in a more dynamic way. So that's one of the things that we're talking about. How can we range, composite range, Z order? This is in tight collaboration with our metadata team and our storage team. Faster eval. This is something that I'm particularly passionate about. And I think we are doing a lot of work. We did a bunch of RE optimizations. We are doing a lot of the optimizations on the Java side. What's quite interesting is that we're also beginning to look at native code. How can we use C++ and kind of LLVM and all those vectorization techniques to make our eval really fast, really efficient. Memory efficiency is really important at Facebook, so we are paying particular emphasis on that. Caching and affinity, I think Alexia people talked about this, Ben talked about it, Ahana and Dave talked about it. Caching is really important. In order to get caching right, you also need affinity. You also need semantically aware cache. You cannot just cache blocks. So we are putting a bunch of work there. We are working with Alexia on the Java layer. We are experimenting with different things internally as well. Format optimizations, we talked about how we can do formats better, especially when the data layout is complex. If we're talking about many nested repeated fields and things like that. We are doing a lot of push downs, etc. RPCs and protocols, we talked about like how we can leverage thrift and kind of binary protocols better. We have a lot of JSON, and then that's often an overhead. We also have a very chatty protocol today. We are looking at like how we can make the protocols more compact and kind of less noisy. Richer metadata, this is again going back to our smarter partitioning and pruning in order to do good decisions, both in terms of complex queries and cost-based and things like that, and also in terms of better partitioning and not spraying every query to every worker, we need richer metadata. This is something that we are looking at to see how we can, maybe we need a special metadata server in Presto, something that can keep this cost-based metadata, cache them, and kind of make it aware the query planning. Various other I reductions, we are looking at materialized views, looking at fragment result caching and things like that. We have, in fact, I think Shishun has a peer out for the fragment result caching, which is very promising. Planning and scheduling. I think one of the things we talked about in the panel was the fact that the Presto planning here is kind of static. How do we make it more dynamic? How do we kind of schedule queries in a more iterative way? How can we make the planner aware of smart decision making as the query progresses? This is a fairly difficult challenge with the current Presto architecture. Same with the adaptive optimizer. Like the current optimizer makes static decisions before the query starts. We want to change that. We want to make decisions as the query progresses. And that requires some fairly fundamental changes to Presto. So we are looking at that. We haven't really fully started scoping or working on it, but this is something that we hope to work on. And finally, a lot of people talked about coordinator high availability and scalability. We have a project which looks at coordinator disaggregation and making the coordinator more efficient and scalable. I think Tim talked about it in one of the meetups. So skip that. On the efficiency side, I think you guys know Facebook has been running a really, really large Presto cluster or a lot of Presto clusters for a while now. Efficiency is super important. We do spend a lot of money on Presto and Spark for that matter. Again, native code, vectorization, all these things are good. And we are doing all of them. Push downs are good, better partitioning, what we call physical design, right? Which is around like how do we adaptively lay out the data in a way that makes query processing efficient. And this is a interesting, essentially what I call FDO, right? So it's a feedback driven optimization. So you look at the query patterns and you see which queries, what are your most frequently used columns? What are the most frequently used filter columns? What are the granularities? And use that to lay out the data in the right way. So for example, you might put the most frequently used columns first when you write the column in the file, so that you can do read coalescing much better. Or you can dynamically cluster the data so that you're clustering on the most frequently used columns. Again, like one of our major challenges is I think how the metadata system is kind of rigid today, and we're trying to figure out how to break that to have richer metadata, maybe Iceberg, maybe extending the Hive meta store. One aspect of efficiency.
Hey, Biswa, sorry, I'm jumping. A lot of people are requesting that your presentation is not showing up. If you just hit, yep, it's perfect. Yeah.
That's good. Okay, thank
Yeah.
you. So workload placement is another important area. Like currently, the scheduler is not particularly smart about where it is placing certain chunks of data based on historical views of how much memory that particular split or particular task would need. This is something we feel has a lot of potential to improve efficiency, to make us run on fewer resources, and also to boost query performance and tail latencies. So we are looking at those. Scalability is particularly important at Facebook because we deal with exascale data. I think people have talked about like exascale has interesting challenges. We have several large pipelines. We have low memory machines. We need them to run reliably. Cost of failure is high, both in terms of delays in publishing and also in terms of wasted compute resources. And finally, we need to do this consistently because we cannot run it in 1 hour today and then 10 hours the next day because the customer has certain expectations. So we have a bunch of projects here. We talked about the coordinator scalability and RPC improvements and dispatchers and kind of multiple coordinators that the firewall project that Tim and Mayank and others are working on. One project that I think Wendy in the past has talked about Unlimited, which is a really cool way of making Presto scale better by kind of materializing intermediate stages. I think a couple of things that are really interesting to me here. One is the Presto and Spark project, which I think is very promising, and it's a great example of open source collaboration of how we can use the best of breed of open source in one domain and combine that with another to make a product that really is kind of best of both worlds, right? So, and on the backside, I'm very bullish on this project. I think Girish mentioned this as well. Another project, I think, another couple of things is that in order to get adaptive execution or in order to get kind of recoverability at the worker grain as opposed to the stage grain, it is very important that we handle shuffle in a disaggregated way. So we are beginning to look at how we can disaggregate our shuffle. This is a very interesting challenge because of the way Presto works. We're also looking at spelling and skew handling and some of the other stuff, which is kind of, in my mind, like table stakes for most query engines. We need to get this right. And I think most of that work has already landed, but we are continuing to improve this. So reliability, right? And in my mind, the reliability has two aspects. One is that it's idiot-proof, right? If really a person like me, maybe, who doesn't really know how to write extremely efficient SQL, but wants to write a lot of SQL, writes those queries, they should still run well. And this requires the engine to adapt, engine to do fine-grained scheduling, to do checkpointing and retries and dynamically adjust plans as we go. The second one is resilience. We operate in a very, very large cluster where machines go up and down all the time. There are network blips, there are file system slowness, and so on. GC pauses. We need to make sure that queries don't fail. Like if you are running a query that is running for 3 hours and one of your workloads die in the middle, your entire query should not fail. We should be able to recover from those things. The third one is isolation. I think Alibaba people, Yang and Co, they mentioned this. Isolation is really important when you have a large multi-tenant clusters with lots of customers trying to run queries on the same cluster. And right now we don't do that great a job at isolation. Like one bad query can essentially hang a cluster or overload a cluster, or one kind of bad user can affect other users. So we are looking a lot into how we can make things better through fine-grained scheduling, accounting, and things like that. So expressibility. This is something that I think we talked about in the panel. This is mostly about improving the developer efficiency or productivity. Like how do we get richer SQL beyond the built-ins through UDF servers? Wrong, I think presented UDF servers, and I'm particularly excited about that because it opens up a lot of avenues for us to kind of run things that Presto does cannot run today, or cannot run in a multi-tenant environment, or things written in different languages, for example. I also mentioned that running over complex structured data is becoming increasingly important as the business evolves and things become more complicated on the data modeling side. Scalars is not good enough anymore. We need to run efficiently over steps and maps and arrays and maps of arrays and arrays of maps and things like that. We have done some good work here as part of the ARIA project. We continue to invest in this. And finally, we are looking at a bunch of extensions. These are fairly early, like the graph one is something that we are hacking, and some of the results have been interesting. We're looking at streaming. I think Girish mentioned that. How do we essentially abstract out the language to handle some of the streaming concepts, especially around windowed aggregation? The others are kind of fairly early in the thought process, so I don't want to spend too much time on those, but we want to get there. So freshness is another angle where we are actually investing a fair amount of resources because we want Presto to be able to query really fresh data. In other words, like we have these logs that are landing like every second or every minute, and now we have enabled near real-time querying, so these logs can be queried as they land, as opposed to waiting for the full partition to land. And that opens up some really interesting use cases around real-time analytics. It does also open up some challenges because when people think real-time analytics, they also mean fast queries, not just fast data. So we have to do some interesting optimizations around like compactions, materialized views, richer metadata, and things like that to make these queries work well. Bunch of these things have started. So with materialized views and fragmentation, caching, and compactions and things like that, which hopefully will be releasing most of this to us, and they are showing pretty promising early results. On the security and privacy side, we continue to invest in kind of custom rewrites APIs, like to implement complex things like differential privacy, for example, which is a kind of hard to get right. End-to-end encryption is another thing that is kind of tricky to get right. In Presto's case, it's probably slightly easier because we control all access through an API. This is an area that we are also looking at, data at rest using Arc encryption and things like that. And finally, how do we provide a consistent interoperable user experience? I think we talked about shared UDFs. We talked about Presto on Spark. We talked about kind of having a common SQL with extensions for streaming graph and batch and things like that, transforms. One of the things that we are doing is this native eval that we are investing in. It is very early stage right now, but we hope to make it a shared eval across our batch and interactive and streaming and some of the other use cases, which will allow us to kind of accelerate development on it because everybody will be working on the same code. And finally, I think I wanted to leave with a comment on community. I think we said this in the panel that sum is kind of greater than the whole is greater than the sum of parts. With Uber and Ahana and Alexio and a bunch of, like, we have done the caching work in conjunction with Alexio. Uber is investigating Presto and Spark. We are investigating some of these connector things that Uber has done to make things really fast with Pinot. There are tons of examples. We are early, starting collaborations early. Results in really, really good outcomes for everybody. So again, like doing more knowledge sharing, more joint planning, more idea exchange around projects is really important. So I want to emphasize that and say, hey, if you have an idea, if you're going to start on the project, if you feel like some of these things are useful to you, come and talk to us. We are in the open source. We are in the community. We should make it work together. And that's it. Thank you.
Hey, thank you, Bishwa. I only see one question right now, which is from Adi. How do you intend to integrate the real-time ingestion?
Well, I think right now what we are doing is really producing org files in real time and have some metadata enhancements to enable us to know which partitions are open. So we can query that data as it lands, as opposed to after the partition closes. We do want to do more deeper real-time integration through things like push caching and notifications of when new data arrives, but we haven't kind of explained that yet. So right now it's a really simple